Okay. The first example is that they are asking us to find the solution of this linear system. So here you can see like we have only two dependent variable and one independent variable. Okay. So and as you can see here, it is the homogeneous linear system, right? Because we don't have the term of constant and we don't have the term as a function of t. So from this, you just cannot use the technique that we are using before. So we got to use whatever I just teach you today. So by doing that, we are going to assume that our x1 is equal to k1 times exponential of lambda t, and our x2 is equal to k2 times exponential of lambda t. So from this, you can write it down as a matrix, or if you don't feel comfortable with the matrix, you can write it down as regular terms as we used to do. So we are going to plug whatever we assume back into our differential equation, as we assume that x1 is equal to k1 times exponential of lambda t. So the first derivative of x1 by t is equal to k1 times lambda times exponential of lambda t. And also for the x2, we just assume that x2 is equal to k2 times exponential of lambda t. So the first derivative of x2 by t is equal to k2 lambda times exponential of lambda t. And then you just plug these two terms, we plug these two terms back into our differential equation here, up here. Okay, and then we replace our x1 equal to k1 times exponential of lambda t and our x2 equal to k2 times exponential of lambda t by plugging them back into the linear system. So we will get here this equation. And then for the first equation, you have k1 here and k1 there. You move this k1 to combine with this term. You would get 5k1 times exponential of lambda t minus k1 lambda times exponential of lambda t. So k1 and exponential of lambda t is the same for both terms, so we take it out. And then, I just do so many terms. I just decide to divide it by exponential of lambda t first. I mean, you can do either one first, that's fine. Okay, it doesn't change any mathematics thing. So I just divide both equations by exponential of lambda t first, and then we move the term, the k1 term together, and for the second equation we move the k2 term together. So we will get equation 3 and 4. From that, we are going to write down the characteristic equation. So we know that our characteristic equation actually is just the determinant of the coefficient term in front of the k1 and k2, right? This term, if you write out as a matrix, you will get here. So this term is just the coefficient of the k1 and k2. So our characteristic equation is coming from the determinant of the coefficients of k1 and k2, and we set it equal to 0. This is the 2 by 2 matrix. So the way to find the determinant is just that you times this and this, and minus with the product of 3 and minus 1. So you would get the characteristic term as this, which is the polynomial equation. So you would get lambda squared minus 6 lambda plus 8 equal to 0. So this one you can write it down in the terms of lambda minus 2 and lambda minus 4. So you have two values of lambda, which is 2 and 4. Okay. After you got lambda, the next thing that you got to do is just find the value of k1 and k2. To find value of k1 and k2, you're going to use equation 3 or 4. 3 or 4, that's 5. So first, you plug the value of lambda 2 into equation 3. Lambda is equal to 2, so you would get what? 5 minus 2 equal to 3. 3k1 minus k2 equal to 0, or k2 equal to 3k1. So if our k1 is equal to 1, your k2 is equal to 3. That is the first step of the solution, saying that if lambda is equal to 2, you would get k1 equal to 1 and k2 equal to 3. So your x1 is equal to exponential of 2t, and your x2 is equal to, now your k2 is equal to 3. So your x2 is equal to 3 times exponential of 2t. Or if you want to write it down in the term of matrix, you would get this form. And then you plug the value of lambda is equal to 4 into equation 3. If you pick up equation 3, you got to use equation 3 for both lambda. If you pick up equation 4, you would use lambda, both two values of lambda to equation 4. Just pick one equation, okay? Because either one you would get the same answer. Now you plug lambda equal to 4 into your equation 3. If lambda equal to 4, you would get what? K1 minus K2 equal to 0, or K1 equal to K2, right? So from that, I would assume that if K1 equal to 1, your K2 equal to 1 too. So your second solution would be x1 equal to exponential of lambda 4t, and x2 is equal to exponential of 4t, which is the same because k1 and k2 is the same. If you want to write down in the term of that matrix, you would get like this. So the general, at the end, you got to combine both solutions in. So you would get x1, x2 equal to c1, 1, 3 times exponential 2, 3, plus c2, 1, 1 times exponential of 40. And that's it.